In this lecture, we'll cover the bit more detailed introduction to Raspberry Pi, so that you'll get a concise idea about how you can go about integrating various sensors and devices with your Raspberry Pi based system and maybe programmatically access and manipulate them. So first of all, we are going to cover how to use the basic GPIO pins, and then we are going to cover how to integrate a Pi camera with the Raspberry Pi for taking images. Point to note is we'll be covering both of these things on Python. So the programming language will be Python. So since it's quite easy and easy to integrate with Raspberry Pi also, we'll be preferring Python. So first thing we are going to go about doing is a blinking LED based project. So basic requirements are you are going to require a Raspberry Pi connected to the network. You are going to require an LED, a basic 100 ohm resistor, breadboard, and a few jumper cables. Okay, so before we go into this any further, let's come back to the Raspberry Pi. As you remember from the last lecture, as you can see, I have not yet powered on this device yet, but I have attached a Pi camera. So this module is known as a Pi camera, and it goes over this side. So you will see this is called a ribbon wire. So it is already available with the Pi cam, and the blue sided should be pointed towards the Ethernet port. This is one point to remember. You take this white jack out, plug this ribbon, and push the white jack in, and that's your that will attach your Pi camera to your Raspberry Pi. So now we are going to power up this system. Now since my device is booted up, I'll check whether we have network access or not. Okay, now we have got a functional Ethernet configuration ready for operation. Okay, so we have got the same IP as the previous example. Now, in the last example, in the last lecture, I showed you how to connect your Raspberry Pi over SSH from any PC. So, using SSH, you can mainly execute and run various programs. Suppose you want to transfer some file. This won't be, this operation you won't be able to do using SSH. You can, but it's quite tiresome. So the easier way out is using a FTP client. So one I prefer is FileZilla. It is available freely online. So once I open the FileZilla, the left hand panel generally shows my local PC contents, and the right hand side will be my remote PC contents. So I'm connecting to the host. The IP address was I put in the IP, username was Pi, password was Raspberry, and under ports you give 22. So this is fixed for FTP. You give port 22 and then quick connect. So it will ask, you will get a security confirmation message. You click OK. Now you are connected to the Raspberry Pi. You can just drag drop between the two file systems. Suppose you want to copy this folder. I've created this folder named IoT. Let's see what's inside. It has 3 files, 2 Python files and 1 image file. So just as an example, I'll transfer this to my desktop. Or better still, I'll transfer one file from my desktop to Raspberry Pi. Suppose I've got this one example.py on my local machine and I want to transfer this to my Raspberry Pi. I just drag drop between the two interfaces. You see, file transfer was done, and now this example1.py is on my Raspberry Pi based system. So if you check again on the Raspberry Pi screen, now there is a folder named IoT. You click on it and there you have this example1.py on your Raspberry Pi based system. So it's quite easy. Many a times programming bigger things on Raspberry Pi is quite cumbersome. So my preference is I basically program everything on my local PC and then transfer the eventual files onto the Raspberry Pi and just do some minor configurations and changes. So now coming back to the Raspberry Pi. So for the blinking LED project, since you are going to connect it to the GPIO terminal, you will require 2 things. First is the Python dev library and the other is the Python rpy.gpio library. So you can easily access these 2 libraries over the net. So once your Pi is configured and ready to go, on the terminal you just type the commands sudo apt-get install python-dev. Once this operation is over, you type the command sudo apt-get install python-rpy.gpio. So once these 2 files are installed on your Raspberry Pi based system, you are ready to go. So for initial connection, I am taking an LED. I'll check for the positive and negative terminals. The larger one is the positive terminal and the smaller one is the negative one. So the white wire is connected to the positive terminal, the yellow wire is connected to the negative terminal. So this negative terminal I'll put to ground, and the positive terminal, for this I'll have to check which port I have assigned. So I've assigned port 11, GPIO pin 11. So it's not quite straightforward as Arduino boards. For this you need to have that reference table shown in the previous lecture. So that will give you a good reference for which pin is which GPIO pin. So for GPIO pin 11, it's actually 1, 2, 3, 4, 5, the 5th pin on the inner side. No, sorry, it's the 6th pin. So now I've connected this. So my connections are ready. On the terminal, I can obviously write my code on the terminal. So best practice is there is a inbuilt editor on the Raspberry Pi named Nano. So you write sudo nano and then file name.py. So if I want to name my file as LED blink, I write ledblink.py. So this will open a new terminal on your system on which you can write your code, Python code. Since your file name is the extension of your file name is .py, you have to write your code in Python. And once your code is ready, you press Ctrl+O. This will write the code to the file, and you exit that Nano editor by pressing Ctrl+X. So this is the code. So first line is import rpy.gpio as GPIO. So this actually calls the GPIO library. Second one is import time. Since we'll be using a delay function on Python, this delay function is denoted by sleep. So we use time.sleep. Third line is GPIO.setMode. So we put GPIO.board. So there are two options. You can use it as a board mode, and there's another option which we are not going to use now. So we are going to stick to this board option, and GPIO pin 11 is set up as the output pin. Then the main looping part, just a simple loop for I in range 0 to 5. That means it will iterate between 0, 1, 2, 3 and 4. 5 is because it is excluded. We covered this in the Python programming part. Now GPIO.output pin 11 is true. That means it will send a high bit to the output pin. It will sleep for 1 second, and again it will send a low bit to the output pin. So the physical output will be once the high bit is reached, your LED will glow, then it will wait for 1 second, then once the lower bit is reached, it will turn off, and again it will sleep for 2 seconds and then turn up. At the end, you do this cleanup operation to release the GPIO pin. So we have already seen on the console this operation. So these are the codes. So one more thing, since the inbuilt Python installation on Raspberry Pi OSs are very rudimentary, you won't be able to access advanced options without installing advanced libraries. So the very basic Python idle interface and editor you will be able to access on Raspberry Pi. So once you double click on this file, this is my file of interest, pyledblink.py. It opens up this code, right? So let us suppose you don't have a visual display anymore. Let's try accessing this thing over the terminal. So I log in into my Raspberry Pi. I go to the directory IoT. Now I am inside the directory. I'll check what are the files and folders inside the directory by writing ls. It will list all the files and folders inside this IoT directory. So my code of interest is pyledblink.py. So first let's see what's exactly inside this file. I write sudo nano py ledblink.py. So it opens up the editor. This is the same code we showed on the slides. It has already been saved. We exit this. Now when I want to run this code, I write Python py led blink.py. This was my LED blinking program. I press enter. As you can see, the LED has started blinking. So, and it will keep on blinking. So, I again run this program. I run this module. As you can see, the LED blinks. The program is executing. Now, once you get this triple arrow symbol for the console, that means your program execution has finished. So, this was the basic integration and usage of GPIO pins on Raspberry Pi. The next interesting topic we are going to cover is integration of the camera or the Raspberry Pi camera. Here we are just going to show integration of Raspberry Pi camera. I am going to place my camera over here. My Pi is booting up. Okay. Prior to this, we'll cover the basics of the camera. So, you'll need a Pi cam and a Raspberry Pi. So, your Raspberry Pi specific camera module, for on the Raspberry Pi you have a dedicated CSI slot for the connection, and the cable slot is placed between the Ethernet port and the HDMI port. I told you before, the end of the ribbon cable you will find a blue tag, and that has to be placed facing towards the Ethernet port. So, once the camera is connected, we reboot the system. So, this reboot operation has already been done. Now, in the terminal, we run the command sudo raspi config and press enter. So, this was covered in the first lecture on introduction to Raspberry Pi. I showed you there were various options, one for enabling the camera, another for enabling the SSH and so on. So, over there you enable the camera option and reboot your Raspberry Pi. Okay. Now, once this has been done, you can directly capture your images using the PiCam by writing on this terminal this particular line of code, raspi still space -o space any image name dot jpeg. So, this will click an image and store it as that image name dot jpg. Now, this PiCam can also be integrated with Python, and the particular module is known as Python PiCamera. So, again you will need to install this library, because none of these libraries are by default available on your Raspberry Pi system. So, you write sudo apt-get install python -picamera, and this is the small code snippet for capturing your images from the Pi camera. using a Python code. So it's a very short script. So first of all, you import this library, import PyCamera. Then you initiate an instance of camera by this name camera equal to PyCamera dot PyCamera. So you must pay special attention to the way it has been written. You see the first PyCamera is all small, then dot PyCamera, P and C are capital. Once this has been initialized, within camera you write camera.capture, then filename.jpg. So these tutorials are commonly available online. You can go for advanced versions, options also. So these things are commonly available on any online resource. So this is one screenshot. You write raspi still -o space image.jpg. So your system will capture an image. So coming back to the hardware part, so we have our camera ready. We have connected it to the your Raspberry Pi to the network, and it is connected to the monitor via HDMI port. Let's open the IoT folder. Now we already have this code ready, that 3-line snippet you saw earlier. So this is the part of the code we are interested in. We simply run this code. Pay attention to the PyCamera module. When it clicks an image, there will be a LED indicator going on. So I run this module. You see this small LED indicator went off. So it has finished taking the image. See, it has taken the image of the roof. Let's try another image. We may delete this image also. Let's point the camera forward. And run this code again. So the code has executed. You see, it has captured an image of the studio. So this is just one of the basic examples of how you go about using GPIO based pins for integrating various small sensors and actuators with your Raspberry Pi, as well as how you integrate larger systems with your Raspberry Pi. More complicated devices like cameras, you can integrate keyboards, mouse, and so on. I have already put up interfaced the keyboard and the mouse over here, through which I am actually controlling the Raspberry Pi interface. You can see the cursor move. I am using the mouse to move it. So this is as good as a computer. Additionally it's very low on power requirements, as well as it's quite cheap as compared to regular computers available on the market. So I hope you will be able to go for more complicated projects using this basic idea. Thank you.